preliminary view on chapters 10 and 11, which will be open on November 14th and close on the 18th, right? So it'll be about the same format as the previous 3 tests have been. Again, I'm dropping the lowest exam score after the 5th exam. And so along with chapter 10, 11 on fluids and waves, also those topics covered, I'll include lab 9, lab 10, and lab 11, pendulum, Bernoullis, and Archimedes Principle are all part of this lab here. Okay, are all part of the exam. These complement that. These are open until the weekend still, and go from there. So, all right, so I'll talk about the topics for the exam coming up here. So I'll go by chapter, section by section. Okay, so we start with chapter 10 on fluids. Again, we're dealing mostly, this will include gases and liquids, depending on, right, so they both act like, there's characteristics of fluids of both of these, and such. So, right, so first thing, density. Again, density is mass over volume. All right, and again, this is either in kilograms per meter cubed or grams per centimeter cubed. And we have the table, so you should be somewhat aware of what the relative densities are as far as everything compared to water. So water has a density of 1,000 in those kind of units, or 1 gram per cubic centimeter, which is why you have specific gravity relative to water. All right, so density of water is 1 gram per cubic centimeter. That's how the gram was defined as far as that is concerned. Okay. All right, so we have density and specific gravity as far as those concerned. All right. So we talk about pressure. So that's the first couple sections. We talk about pressure. Pressure P, all right, is force over area, which is in newtons per meter squared, as far as units are concerned, or this unit is called a Pascal. And force is the weight of what's above it. So this is the force, and it's on an area this way, based primarily on gravity for most of what we're going to be dealing with. Okay? So that's what we have there. It's equal, even though it depends on the weight on any object in a certain depth. The pressure is the same on all sides. This is what we call hydrostatic. So the pressure on the top and the bottom are the same as long as the object is relatively the same, not too large in size. So the pressure is not what makes it sink, it's the weight of it relative to the water. So, all right, and pressure then in the depth is rho GH. So we're going to get into pressure as depth. All right, so for water, this would be, again, 1,000 kilograms per meter cubed times G, which is approximately 10. So it's approximately in pascals, where H is in meters, it's approximately 10,000 times H. All right, so we've gone through that before. We have Pascal, so 1 atmosphere is 101,000 pascals. All right, we've been through this before. And pressure goes as depth-wise in water. Right, every 10 meters for H is 1/8 atmosphere. All right, so that's the pressure in atmospheres, sea level pressure. Okay. Okay, so that's what we have there. I've gone through all that. Do you have any? So that's section 10.3, section 10.5. We've been through. I'm not doing anything in 10.4 as far as atmospheric gauge pressure, but in pascals. Principle. Again, pressure out equals pressure in, which is force out over force in equals area out over area in. And this has to do with like hydraulic lifting, as we talked about in section 10.5. So the force is proportional to the area of what you are setting on. So we talked about that before with hydraulic, trying to lift up a car with a relatively small force. Okay. So you have the units. All right. Not going to go through those. All right, so that's the section there. It's section 10.5, section 10.7, Archimedes Principle. And this is where you have an object in the water. So, all right, again, force in air, we'll call that force weight in water. And based on Archimedes Principle, you have this weight in water is the weight in air, if A minus the buoyant force. So the weight in the water is weight in air minus the buoyant force. And then from there we get the density, which is weight F in air minus F in air minus the weight in the water, right? It's actually equal to that over the buoyant force, but we can't measure that directly. We have to take the difference, and I went through some examples of that. So this is the expression for calculating density by weighing the object in water, like Archimedes did to discover the weight of the crown, whether a crown is made of gold or lead. Okay. So that's section 10.8. All right, section 10. Oh, that was section 10.7, I should say. 10.8 is we have continuity equation. I went through this, and that's A1 V1 is A2 V2. So again, that's where I have and it can either go in or out. So this is 1, 2, so the velocity V1, V2, and the product, so this is A1, and this is A2. The product of A1 times V1 equals A2 times V2. I went through that part there. All right, so that's the principle there. And then the last thing, I think the last section. Yeah. So that's section 10.8. The last section, 10.9. Bernoullis Principle. And this is where P1 plus, simplified to this, 1/2 rho V1 squared equals P2 plus 1/2 rho V2 squared. That's the equation, and basically what this is related to is the plane wing. So if this is P2 and this is P1 and a V2 and V1, so basically since it's going farther, V2 is faster than V1, then P2 will be less than P1, and that's what lifts it up. All right, so the pressure here is great, and this is the air flowing over it as far as the plane wing or other characteristics concerned, as far there. All right, so that is chapter 10. All right, next thing I'm going to do is go on to chapter 11 and cover that aspects. All right, so that's chapter 10. All right, chapter 10 is oscillation and waves. All right, and for that we have simple harmonic motion, SHM, and that's either for a spring, a pendulum, so pendulum, which we talked about, or a spring, oscillating spring. Both of those have periodic motion, meaning if we look at the amplitude versus time, then the amplitude follows a cosine or sine function, given by what we call cosine omega t or sine omega t. So it has a periodic function, periodic pattern, similar to a sine and cosine. Right. All right, let's see, we define the frequency as 1 over the period, which will be in seconds. So this is in what we call hertz, cycles per second. Okay. Again, we look at the total energy. All right, both of these are generally conserved, so the total energy equals kinetic plus potential energy, which if you look at lab, I believe that was lab 8, I believe. All right, so the potential energy for a pendulum, well, all of them have kinetic energy of 1/2 mv squared. For the pendulum, or it's basically going to be the potential energy is mgh, or how high the pendulum is above its lowest point. And for spring, the potential energy is 1/2 kx squared, which we define both of these as spring constant and the distance from the equilibrium point. And so the total energy is constant, as we talked about, because both of these are what we call conserved systems. All right, so keeping that there, moving on, just keeping the labels up. for a pendulum, the period is given by 2 pi L over G, where L is the length of the pendulum. And for a spring, T is 2 pi M over K, where M is the mass hanging and K is the spring constant. Notice the similarity between the two. Notice also what factors, again, we've talked about, depend that affect the period of pendulum and what 2 factors affect the period of a spring. So that's section 11.3 and 4. So this is 11.4 for this part. We're not going to do anything with damped harmonic motion. And then we're not going to do anything with resonance. Then the last section we'll cover, talked about, is, well, we have the speed of a wave. Speed of a wave is frequency times wavelength. So this is going to be meters per second. This is in 1 per second. This is in meters. So frequency times the wavelength of a wave. And again, when we talk about wave motion, all right, we had, and I'm just going to put it up again, we have transverse, and compression. And I'll just show the picture again, all right, from the book, showing the top is a transverse wave. Notice that the spring vibrates up and down, but the wave goes to the right. In the compression wave, it vibrates back and forth, and the wave goes to the right. So that's different. You call them transverse waves, sometimes in solids or shear waves. Compression are called longitudinal waves also in that respect. And then we also talked about what kind of waves. We talk about earthquakes. A transverse wave can only pass through a solid, and a compression wave can pass through a solid, liquid, or a gas. And this is, related to why sound waves in air are compression waves, and why in earthquakes, depending on the material, how you can determine the characteristics. The earthquake produces both of these, but only transverse wave can go through. It can only go through solid, while a transverse wave cannot go through liquid. So if part of the interior of the earth is liquid, the transverse waves will not penetrate through there. So that is the characteristics of chapter 11. And then we had standing waves. We not forget that. Resonance. This is section 11.12. And show you that part. Okay. And just the fact that we have a standing wave, as we've talked about, all right. The top one is a half lowest one, half a wavelength for the whole length, L. Second one that's a full wavelength, and the bottom one is a wavelength and a half. And notice where we have node and antinode for the fundamental, second harmonic, third harmonic. All right. So we're going to call the first, the ground, the first harmonic, and everything is multiples of that. We're not going to do anything like refraction or diffraction, because we'll get into that when we do light, because it's easier to observe those with light, which will be in Physics 1102 if you take that course. So that is the summary of chapters 10 and 11. So good luck on the test, which starts on November 14th. And you again get one attempt, and there'll be mostly multiple choice questions, but a few short answer questions. All right? So, and don't forget the review quiz questions will close on the morning of the 14th before the exam